It's my pleasure to introduce Kristian Mattarochia. He will be talking about GFE is not the forecast, the historic winter of 2022-23 in California. Go ahead, Chris.
Thanks, Mike. Good morning, everyone, and thank you for inviting me to speak this morning. So I'll start off by saying that first phrase in the title slide is probably pretty revolutionary to some, but we were able to pull it off here before the wettest winter in California in about 150 years. So we were lucky to have such a busy winter on our hands to get people to not spend so much time with grid editing. So I'm going to talk about the long process that we went through in order to get to that point. This wasn't just like a month or 2 month thing. This was actually a 5-year process to get folks comfortable with not touching GFE. So these are some of the slides that I'll be presenting and some of the stuff that I'll be talking about. We're, always moving towards forecast modernization, targets of opportunity. Some of the tools that we used in order to begin this process of getting people to understand that just putting a value in a 2.5 by 2.5 kilometer grid point is not providing any type of decision support to our partners is by reviewing the usage of model data that we had available to our meteorologists, reviewing the tools that they were using. So we used the GFE tool inventory from the SCP. And then I actually sent out a survey which asks people, which are some of these databases that you use. And of course, these databases mostly were targeted for elimination. But what I wanted to do was figure out one by one what people were actually using, so then I could have a meeting with that one person and talk about, okay, why do you use this? Why do you feel this data set is better than the NBM? And talk about how we can get them to step away from that particular data set and why the NBM being calibrated is going to be a better way to go with. And ultimately, we're still not going to really be able to message our impacts with GFE. So that's what I talk about here in the bullet points. Laying the foundation, first of all, just bringing up the topic of the modernized forecast operations concept. GFE cannot capture our core partner impacts because our topography here is crazy. I'm actually going to drive the Yosemite National Park today, which is in our county warning area. It's about 3.5 hours away. I could beat it 10,000 in about 3.5 hours. Where I'm sitting at right now, I'm at 250 feet above sea level. So that's a pretty drastic change. Again, I use the GFE tool inventory to gain information from each user to see what they were doing, so I could tailor my one-on-one meetings with them to figure out how exactly to get them away from leaning on those tools so much. And then we also wanted to get rid of the antiquated model databases. It's really no more reason for bias corrected models anymore. The NBM has a far more robust bias correction system than our former way of bias correcting did. It was great. That's what we had at the time, but we have something that is much better now and far more supported. And of course, we have Forecast Builder on a cron starting at hour 1. So what we wanted to do is get people comfortable with staying out of GFE as much as possible. So there are some times when we do have to make edits. And of course, those are referred to as targets of opportunity. And, pretty much we pulled this just straight from the MFOC document as to what it is not and what it should be. When our messaging is drastically changed, okay, maybe we have to make some edits in GFE, but ultimately, even when we have drastic changes to our messaging. By the time that we get into GFE, make the changes, publish, send to NDFD, it's not really going to quote unquote hit the streets for an hour, maybe 2 hours, based upon how busy the network is. And the impact may have already been over, or the decision that needed to be made may have already been made, and folks don't have that information in their hands if we're just relying on GFE to message. So when I sent out the survey as far as what smart tools people use, this was some of the results, and not surprising that it's really smart tools that are just about cosmetic changes to make the grids look pretty. Model blend was a big thing, and of course the NBM is a model blend. So why are we model blending when we already have a robust bias corrected model blend? SERP, of course, is probably one of the worst ones. I will say that our IRMA grids still suffer some of the effects that SERP had on our OBS grid, and that going into bias correction, and that ultimately going into RTMA and IRMA. So still working to even get rid of some of those. It's so drastic with our elevation. So the one tool here that we did decide to end up keeping for a while, and we still do, is the make wind gust. The folks felt pretty strong about that because the NBM was, at that time when we started this, still suffering from some large biases with wind gusts, especially in our higher elevations. So then we talked about model databases. Again, it's important to state that these models are in NBM, so there's no separate reason to use this when we already have them available in NBM. So the bias corrected models were mostly targeted, the cons short, the cons all, the cons are all that stuff, which is not calibrated and quite frankly is subjective, which is, using OBS grid in some cases. That was kind of my goal, although I didn't really put that out there to our folks until we really talked this through. So this image, and I know not all of you have elevation, so you can't really provide this example, but it makes sense even if you're dealing with flat territory, because we know, for example, temperatures, you can't just assign an ASOS value to a temperature. You can go 100 yards down the road from that ASOS, the temperature could be off by 4 or 5 degrees. So, what are we doing trying to nail temperatures? But the image you see on the left, the yellow star is the bottom of Yosemite Valley, which resides at 4,000 feet. But very close to there and within view is another important decision point for Yosemite National Park, which is Glacier Point. And that point is at an elevation of around 8,000 feet. But unfortunately, because of our GFE resolution, Glacier Point is assigned the elevation of Yosemite Valley. And there are roads on Glacier Point. There are people camping there. There are people hiking there during the winter. So it is very frequent for it to be snowing 2 inches per hour at Glacier Point, which is at 8,000 feet, but in the valley where most of the people are staying, most of the hotels and most of the headquarters are located, it's actually raining. So GFE can't capture that. We have to message that separately. And we can deal with these huge problems that we have with elevation change by using probabilistic forecasting. Now, during the winter of 22-23, we had record snowpack pretty much all throughout the Sierra Nevada, and that included Yosemite National Park. So, when we talk about flooding, when we talk about rain on snow, when we just talk about heavy snow in general, we were having roof collapses. If we spent all our time trying to fine tune GFE, we would have been doing a disservice to our partners. And Yosemite is one of our biggest partners. So again, my soapbox mantra is GFE is not the forecast. And that is very true, as we just saw in the previous slide. So I thought I would provide an example from very recently, just so this would be more applicable to what we're dealing with over the past couple of days. I will say, going back to the winter, that what we did is we tested this during the fall of 2022. Okay, this was before our cataclysmic winter, and I'm not being hyperbolic when I say that. So basically what we said is, let's try this out, see how it goes, and let's put a 90-day test period on it. And if we don't like it, or we want to kind of go back to the old way, we can do that. And that's important for our culture, for our forecasters, so that they know that we're not locked into this. We're just trying it out, that we can go back if things don't work out. That's a good strategy to have. But what ended up happening during that winter is that we had so many conference calls, so many deployments, which is very unusual in this office. This is not a very active office, except during the winter time. And sometimes during the winter, there's a drought. So it's not even active during the winter. But if we would have spent as much time editing GFE grids that we had done in the past, we never would have been prepared for the cataclysmic winter of 22-23. We had so much rainfall, so many atmospheric rivers, that something called the Tulare Lake reemerged for the first time since 1969. Now, that lake was naturally there before Europeans came to California, but we had so much rain that it reemerged. So that's how crazy that winter was. So this particular image here is something that we stress, is that, you know, getting a weather story up, getting a weather story on Slack, Facebook, Twitter, picking up the phone and calling our partners, updating our partner email, is going to get the message to our folks a lot more faster than doing editing of the grid. So we had an event that just happened recently. So this was just on Monday, where we had a little bit of tropical moisture sneak into our area that no guidance really picked up on, and we didn't really have much of a mention of thunderstorms in our forecast. But what happened is that we have had such wet winters, and we have such thick grass that has cured, that it's very easy for grass fires to break out. And we had an event with dry lightning. We were mostly getting rainfall amounts less than 1/10 of an inch. And this was happening, and we weren't messaging it previously. So when we saw these thunderstorms developing, we started putting out special weather statements. But we also put out this slide on all of our communication and messaging channels. And within 15 minutes, one of our great partners at our ABC affiliate broke into the broadcast and said there's an increased risk of grass fires from all the dry lightning strikes out there. There was about 1,000 lightning strikes in like 3 hours in Fresno County, which is our most populated county. So we never could have gotten our word out that quickly, that effectively, and even got the media to break into a broadcast if we were worried about what our pop grids said, or what our potential thunder grids even said. And this is just an example of that particular day. So like, I got a question from CAL FIRE in Slack after that slide was issued in Slack. There's an image of the tweet from CAL FIRE about all the lightning strikes and all the grass fires that had broken out. Now, we didn't have any dry lightning or thunderstorms in the grids. Well, so what? Like I said before, if we would have spent all the time to edit the grids and send them up to NDFD, by the time that information would have gotten into GFE and gotten into our quote products, the event would have been over, or the fires would have already broken out. So we needed to provide decision support immediately and start messaging impacts immediately. And again, there's no way we could have done that if we were twiddling with the grids or making edits. So what we stress is that any near-term weather changes need to be handled by messaging and effective messaging. So partner emails, conference calls, Facebook and Twitter, I wouldn't say always are effective messaging. weather stories, and you can see this slide's a little bit old because I say NWS chat, but I should have Slack in there. But we emphasize that there should be no editing of GFE grids because it takes too long, first of all, and we need to help people make the best decision possible. And us being buried in the grids or even having just one person editing grids is not going to accomplish that. So I talked about the 3-month experiment before, and these were some of the guidelines. So all of our forecast edits, if we made any, need to be completed through Forecast Builder. No boutique tools or procedures that we only used here at this office that would cause our NDFD grids to look out of sync with our partners. We did decide to hold on to our near-term high-res models. So the HER, the HRF, the NamNest models we held on to because they handled wind gusts better than the NBM. We still left the option for edit retention to be used to create dynamic edit areas where we know that NBM has proven problems. But again, that is very rare that we even rely on that now. And I already talked about us keeping the make wind gust tool. So what's interesting that after the 3-month deadline expired, or we got to that 3-month end, which ended in December of 2023, nobody even noticed it. No one even remembered that we were only supposed to be quote unquote doing this for 90 days. So we didn't get any pushback at all. Everything went well. It gave us more time to deploy and focus on the major impacts and decisions that we're making as far as water and snowfall and flooding during the atmospheric rivers in 2022, 2023 in California. And actually it got to the point where I had people coming to me saying, I'm so glad that I don't have to spend time editing GFE grids, that I can just get straight to the point. And even, I'm not trying to pat myself on the back here, but we had folks that would TDY into our office because we were stretched so thin coming from Montana. And they were like, wow, this is so great that I don't have to even worry about GFE. I just let Forecast Builder handle that on the cron. So, really, and most of us know this, SERPing, nudging, and blending really only create cosmetic changes that make ourselves feel happy and feel like we're doing something, but really don't affect our messaging that greatly. Probabilistic messaging is much better at handling chaotic weather elements over short distances, especially with topography. And once we get to the point where we have tons of probabilistic grids, we're not going to be able to make changes to those to help people make better decisions. So we need to focus our energies on messaging, what the weather enterprise sees and feels, which is best case and worst case, and freeing operations from the constraints of GFE gives us more power to be meteorologists because we're not so deterministic. We're more able to be a scientific first responder and act as soon as we see a change occurring instead of going directly to GFE. So that's the end of my presentation. I understand that this may not be fully possible at all offices, but I just wanted to give an example of where we did it and where it worked and where it's still sticking. So we've been in this posture now for almost 2 years. So with that, I'd be glad to take any questions. Thank you.
Yes, if you have any questions for Chris, please raise your hand or put it in the message. Chris, I have one question. Dealing with complex topography and in forecasting in those areas, were there any issues? I mean, this is getting back to the issues with Forecast Builder. How, for instance, did it do a good job handling snow levels and rain, snow, where you had to bring in other tools to handle that? Because I know that's a big issue, especially with those atmospheric rivers that you have, because you have transitions and stuff. Were the tools that we have good enough, or did you have to modify some of that for the forecast?
What we had, let me just say that I don't think there would ever be any model or tool that would be able to handle the challenge of snow level in rapidly changing topography. Um, what we got from the NBM was sufficient enough, and we knew it wasn't going to be right on, but we were able to apply our meteorologist expertise about the area, about how quickly snow levels change. They don't like change every 6 hours, like, or even every hour, as slowly as what GFE would indicate. When you have evaporational cooling, you can go from a snow level of 8,000 feet down to 4,000 feet in 10 minutes. So we're able to communicate that with conference calls and briefings. But no, it's not always handled well in GFE, and I don't think it ever will be handled well in GFE, even though we have the NBM, which is a blend of all with conference calls, briefings, right in time messaging, so we can say, hey, look, 4 or 5 hours out, although it's raining at 4,000 feet, cold air is going to come in. There's going to be a rapid change to a place like Yosemite. So, you really need to ready up your snow removal equipment and, consider making some decisions about what's going on in the park. And GFE is just never going to be there, never going to do that. The one difficulty is that we still have so many, even some of our probabilistic messaging and some of our images are still tied into GFE, so that hamstrings us a little bit. But the more and more we get towards using tools like DESI and using the Extreme Forecast Index and things like that that aren't tied into GFE, it makes it easier for us to message some of these very critical things like a quick change in snow level.
Sounds good. Last call for questions for Chris. Go ahead, Chris.
Hey, Chris. Obviously, this talk's a great segue into the next one. I wonder if you could just talk a little bit about, you mentioned kind of the quick spin up messaging. You can't even maybe take one person to worry about the short-term grids, but maybe talk a little bit about what that looks like collaboration-wise in your office. Is it kind of one person that does the key message crafting or the message crafting, or do you kind of do that as a team? Or do you bring in, maybe the people in the office that are really good at writing these messages? Maybe just talk a little bit about your experience with the message crafting process in the short term.
Yeah, sure. So when we have our morning huddles, although it's not always brought up, we have a living, dynamic key messaging or key messages document that we're always updating. So in that document, we will highlight, the possible concerns of the day or what could go extremely wrong if it did happen. And that was sort of brought up, although it wasn't in the models. It was like, well, if we do get some lightning, it could be dry and there could be a lot of grass fires because we've been having that problem. So at the beginning of the day, we kind of had that in the back of our minds that this is where the train could go off the tracks. As far as from an operational perspective, usually we will have everybody involved in the messaging. Typically one person will handle, weather stories, conference calls, things of that sort, getting in contact with partners. But sometimes we need 2 or 3 people to do that, depending on how big the impact is. So I would say we don't really assign it to one person. We try to do the ICS structure where we have one person that's responsible for, maybe the forecast and the other one does IDSS. But in a rapidly evolving environment like this, we leave it up to our forecaster in charge to divvy up those duties so they're done efficiently because they know best the skills of our meteorologists. So it's kind of like an all hands on deck type of thing, I'd say.
All right, last call for questions for Chris. Looks like it's it. We really appreciate you taking the time, Chris, to present for Central Region. Thanks again.
No problem. Thanks